Anyone who has inspected an electronic circuit maybe noticed that there is always a component, resistor. In fact, its use is so widespread that it's difficult to think a circuit without it. In this video, we are going to analyze this component and its common uses, referring to another video for more specific subject. So, let's explore resistors. Well, we can start saying that the main goal of a resistor is to limit the flux of current into a circuit, or easily decrease the voltage between 2 points. This is possible thanks to a characteristic of resistor, resistivity. If we consider a direct current circuit and a conductor with a cylindrical shape, like a wire, we can calculate resistance with this formula, where ρ is the material resistivity, L the length of wire, and A its area. Furthermore, if the temperature increases, the ρ factor increases as well. For this reason, when we design a circuit, we always keep an eye on the powers involved. Generally, you can use this formula to calculate the power dissipation of resistance, otherwise we could degenerate heat and could burn our circuit. Last but not least, keep in mind when we talk about resistor, we are considering the real component. Resistance is a physical characteristic of resistor. Okay, after this hint of theory, let's move on practical aspects. We can start from the symbol uses for resistor. There are two ways to represent them in a schematic, American version and European version. The first is certainly the most used. The unit to measure a resistance is ohm, and the symbol used is ohmega. We can have many types of resistor realized with different material, and as you can imagine, it's impossible to create a specific resistor for every value of resistance. The most common value series is the E12, that provides, 12 different values for each decade. In fact, the range provided is from 1 to 8.2. There are other E-value standards, and if you are interested to convert a custom value into any E-standard value, you could use this function of my app. So the question is, if I buy 1 kilo resistor, will all of these be 1 kilo? Unfortunately, the answer is no. This is because there is a factor that is called tolerance. For instance, generally, these blue resistors have 5% or 1% of tolerance. Instead, these beige resistors have 10% or 20% of tolerance. To know the tolerance value, you can check the color of the last band of resistor. In this case, we have 1 kilo resistor with 1% of tolerance. If you are interested to know more about the meaning of colored bands of resistor, I made a specific video and there is a function in my app to quickly know the tolerance value. In fact, if you use a multimeter to check the real value of 1 kilo resistor, we will find that the real value is 919 ohm. Before to go to the lab, we need to know the last things about the resistor. It's the power rating. Generally, commercial resistor can handle 1 over 2 watts or 500 milliwatts or 1 over 4 watts, that means 250 milliwatts. If we forget to consider the power rating, we will have the magic smoke, and to be honest, it's not so magic, especially its smell. If our circuit needs power, we can use the power resistor. These kind of resistors are perfect to handle big power. For example, in this hair dryer circuit, we can use power resistor to generate heat from resistor. This is also called a Joule effect. So thank you, Joule, for keeping us always fashionable. There are other types of resistor, for example photoresistor that change their resistance according to the light that they receive. Another example could be thermal resistor that change its resistance according to the temperature. Eventually we have the potentiometer, that is a 3-terminal resistor with a sliding or rotating contact that form an adjustable voltage divider. Great, so finally now we can go to the lab. We can consider two main configurations, resistor in series and resistor in parallel. Okay, let's start with two resistors in series. If we run the simulation, we can see that we have a voltage source of 5 volts and after we have a resistor of 2 kilo ohms and a voltage drop of 2.5 volts. After we have a second resistor with a voltage drop of 2.5 volts. You may have noticed that the voltage drop across the two resistors is the same. This is because when we have a series connection, the current is the same, and in this case the value of resistance is the same. Okay, Let's see the parallel configuration. First, we need to run the simulation. As before, we have a voltage source of 5 volts and 2 resistors. In this case, the voltage drop is the same, but the current is different. If you may have noticed that the current is the same, this is because, as before, the value of resistance is the same, and the voltage drop is the same as well. Okay, let's move on to the last section, when we will see the typical application of resistors, but first I want to do something more. I want to check if also cables have resistance, and as you can see, yes, they do. In this case, it's very low, so we can ignore it, but remember, when use a bigger cable, check always its resistance. The first typical use of resistor is as a voltage divider. In fact, if we connected two resistors in series, we can have a calculable output voltage. So, with this circuit, we create a stable power supply? Unfortunately, no. In fact, the output voltage strongly depends on load resistance. As you can see in this video, in fact, if I change the load resistance, the output voltage changes as well. This is a bad behavior for a voltage source. There is always a dual of this configuration, and it's called current divider. As always, if you want to know more about current divider or voltage divider, I created a dedicated video, and there are two functions in my app to calculate each parameter that you need. Perfect. To conclude this video, let's see the other uses of resistors. One of these could be the attenuator, that is the opposite of an amplifier. Furthermore, we can use them to limit the current into a circuit, for example in a series with a LED. Last but not least, we can use resistors to create RC or RL filter circuits. This kind of circuit could be used in many ways. One of these could be as an audio filter. So, that's all for today. If you like this video, let me know lighting up like button. If you have a question, please don't hesitate to comment. Don't forget to always expand your knowledge, and we will see in the next video.